Hello all. Today we are going to see scientific calculator using LEX YACC. LEX. LEX is a program that generates lexical analyzer widely used in Unix. Lexical analyzer which generate tokens means basic functionality of lexical analyzer is separating the token. Here these are the meta characters and matches. In LEX programming, we are using some patterns. So these are the patterns. Dot. Dot means any character except new line. Mostly we are using for the purpose of echo. Then slash n representing new line. Star representing zero or more occurrences of preceding expression. Plus means number of more than one occurrences of expression. This question mark 0 or 1 copy of the expression. Beginning of the line. Then dollar means end of the line. This represent A or B. This represent one or more copies of AB. Then this represent literal because it is present in double quotes. These are the double quotes. So this is a literal and this is a character class. Mostly we are using for the regular expression or the patterns. So these are the some meta characters used in LEX. Now we'll see some examples for the legs. Here you can see ABC matches ABC. ABC star means ABC, ABCC, ABCCC means C star means C occurs 0 or more number of times. We learn this concept in TOC, theory of computation. Then ABC plus. Here AB is compulsory. This C is having one or more occurrences. So matches ABC, ABCC, ABCCC in this way. Same way A in bracket BC plus means more occurrences of BC. Then here either will take BC or not. So matches A or ABC means which strings are forming this expression. Then this ABC, one of the A, B, C because we took in square bracket. Same here A to Z, any letter from A to Z. Then one of A dash Z. Same here. Here one or more occurrences of A to Z, capital small letters as well as 0 to 9. This is a alphanumeric character because here we can combine anything. Same here, white space, slash n, slash t and space that can be accepted. Here anything except A, comma B because this raised to the power, this operator is there. Meaning of this one is except A or B means we cannot take A and B. But here we can, meaning of this one is A or this raised to the power or B, any character in between. Then this is meaning is A or B, any one of them. Then the meaning of this one A or B. A or B. We can take A or B. So these are the examples for the expression. So these are the patterns. Pattern matching example. Now Lex is having three sections. Means first section is definition section, then second section is rule section and third section is code section or the subroutine section. All three sections are divided by this dollar sign. Means this first section, then dollar, second section dollar and third section. In definition section, we are writing some declaring variables and header files. Then in rule section, we are writing patterns or the regular expression related to LEX programming. And in code section or the subroutine section, we are writing C codes. means function call or printf statement. All these functions we are writing in C code section. So this is the pattern for LEX. Let us consider this is a simple example where we are echoing the output, means whatever we enter that will show, means this is in first section, means in definition section there is nothing. Second section is rule section. In rule section we wrote dot and echo. Dot means any character other than slash n, means any character we can accept, only dot. And then third section is a C section or the subroutine section where we have wrote some functions YYWrap and main function, where YYLEX function is there to call the lexical analyzer. So it will display the output. If I enter ABC, it will show output as a ABC. If I enter hello students, then it will display hello students in this way, because my input is dot, any character. So this is the, in this way we can write the LEX program. So in LEX there are some functions YYLEX, YYWrap, and some variables like YYText, YYLVAL, YYLength. So first, what is YYLEX? Call or invoke lexical analyzer and return tokens. So this is an inbuilt function of LEX. Then YYText, it points the match string, means whatever token is separated by lexical analyzer that is stored into YY text. This is an inbuilt variable whose type is character array. So it is a pointer variable. Then YY length, it is giving the length of matched string, means it will give the length of YY text. Then YYLVAL, value associated with the token. If my value, if my string is 123, but that is in the form of character array, but I want convert that 123 in integer, then I will use function a to I or a to f, then that value will come in YYLVAL variable. So value associated with the token. Then YYWrap function, it is a function return 1 if done, if 0 not done, means if it is a, this is related like error only. Then if we are using file, then these are the file handler YY out and YY in, and whose data type is file. Then initial, begin, these are the initial start condition and switch case. And echo, write the match string, whatever we enter that will show on the screen. So these are the predefined variables and functions in LEX. So let us consider this is a simple example of LEX. Here digit, this is a variable we have declared, or we can say digit, and which is having 0 to 9, any character between 0 to 9, letter in between capital A to Z and small a to Z. Now you can see here, this is first section. This first section is definition section. The next section is rule section, where we are writing the patterns or the regular expression, we can say. So here letter, then letter slash digit star. What is the meaning of this one? Letter and letter slash, letter or digit star. This is a identifier. Minimum first character should be letter. So this means any character, small or small letter character or big letter character, and then onward letter and digit, any combination of letter or digit. And here we wrote star. Star means either we can take or zero combination. So minimum character is one character and number of. So this is the format or the pattern for identifier. Then in subroutine section we call lexical analyzer, and we took the input from user on command prompt, and with that we shown the identifier count, how many counts are there. So we took variable as a count, and when if we separating the token, that count is incremented over here. Suppose I entered hello word, means hello is one word, and hello is one word, and world is another word. So it will give output as a 2, means number of identifier 2, because hello it will work HEEHELLO, in this way it will work. So this is a simple program of finding number of identifiers in the program, in the line. Now next is YACC, yet another compiler. Again, YACC is nothing but we can say parser. In YACC, there are three sections divided into three sections. Again, first section is definition section, second rule section, and third one is a subroutine section. And these sections are separated by this double dollar sign. In YACC definition, there are some declaration we are using. Dollar start, meaning line, means the whole input should match the line. Then dollar union, list all possible types of values associated with the part of grammar. Then dollar type means gives an individual type for values associated with each part of the grammar. Then token, separated tokens by the legs. So these are the some declaration. Again, we are using in program, for calculator program we are using dollar one, dollar two, in this way. So what is the meaning of dollar? So dollar is representing resultant value for any part of the grammar. We will see in details. Then dollar one and dollar two represents values for sub part of the grammar. Means E is equal to E plus E. Means E plus E, that E is representing dollar one, then another E is representing dollar two, and final output of this one is representing dollar. So this dollar is the resulting value. Now YY parse. YY parse is a routine created by the YACC from expected input action. Then next is YY-LEX, routine called by the YY parse for all its input, which we saw in how lexical analyzer and parser are working. Lexical analyzer passing the tokens, and on that token parser is working. Again that parser is asking for next token. So in this way YY-LEX and YY parse are communicating with each other. Then one more routine is there, YY error, which is giving the error or the detects the error in parser. Now we will see the calculator program. So here we are going to see scientific calculator. In scientific calculator, arithmetic functions as well as sine, cos, tan, then cube, all these functions we are going to see. So let us see, this is the LEX file. So LEX file is having extension .l. So here is a LEX file, L, cal.l. So this first part is a definition section. Here we have declare math.h. This is a, in this bracket we declare math.h. This math.h file is required because we are going to use the sine, cos, tan function, and all these are coming from math.h file only. And then one more file is include that y.tab.h. This header file is generated by parser, which we are using here in LEX program. So this is the first section, definition section, where we have declared two header files. Now next second section is a subroutine section, rule section, sorry. Second section is a rule section where we are writing the regular expression or the patterns, we can say. So for our program, as this is a calculator, so we need to take input as a integer or float. So this part is representing float value. So first this 0-9 plus indicates integer. This integer, this or 0-9 star dot 0-9 plus this part indicates float value, means either we can take integer or either we can take float as a input for number variable. So if I enter 123, my input is 123, then this regular expression or this pattern will match. If I enter 0.23, then this part 0.23 means there is no value before decimal. So only point and then 23. So 23 over here. If I enter 59.23, then 59.23. So in this way, that token will separated, and that separated token is coming into YY text variable. It is a inbuilt variable of a YACC. So, and finally we are converting that variable token into A2 using A2F function. A2F function means expression to float, means we are converting that into float and finally storing into YYL. So YYL is the value, inbuilt value we are storing. And finally we are returning in the form of num. So this num variable we have declared in YACC file. You can see here we have declared in YACC file. So this part is the entering variable number, integer in the form of integer or in the form of float. Now next is, if I took input as a sine 45, sine in bracket 45. So sine is mathematical function. For that I wrote here sine, S-I-N. We can take any token name. So this is a user defined sine name. But this is a mathematical sign. Same for cos, it will return COS. Then cube, it will return cube. Square, ln, if it is there ln, then return ln, tan, log, square root in this way. Means here we have matching the tokens, but actually we are going to do mathematical functions. And if it is tab, it is accepted. If it is slash n, then return the output, and our output in the form of YY text. So this is what our second section, that is a rule section. And finally subroutine section, which is not present here. So in cal.l we have wrote number of patterns for number and for mathematical functions like sine, cos, tan, all these things. Okay. Now we'll see YACC file. So this is using cal.l we are separating the tokens because our input in the form of arithmetic expression or mathematical function. So now next is YACC file. Again in YACC file, first section is definition section. So you can see here, this is our definition section. Whole section is definition section. In over here, we are using different tokens like sine, cos, tan, log, all these tokens. So these tokens we have stored or the defined. So first section is definition section. We declare these two stereo.h and math.h. Stereo.h is required because we are using printf and scanf like this. Then math.h is required because sine, cos, tan functions all are mathematical function. Then next is union, because in union we already saw union lists all possible type of values associated with the part of grammar and gives each field name. So this union is used over here. So double P. We have declared a variable P whose data type is double because we are taking input in the form of number, integer number or the float number. So we declare the data type. So this is a union. Then tokens. Which tokens we are going to use? These are the token, num token, sine, cos, tan. So we all declared over here. These tokens we lexical analyzer separating and passing to the parser. Over here num is having data type P, that is double data type. So we wrote over here, and then these are the just character array. So directly hash token. Then in array, this is what second. Then next is we are going to use different operators, as this is a calculator. So we need to use operators. So plus, minus, multiplication, divisions. Here this left dollar left indicating associativity of that operator. So this is a left associativity, and here precedence of the operator. So this is the precedence. The plus, minus, left associative, same star, hash are left associative as well as having the highest priority. Then next is a one variable we are going to use, that is the exp, which is a non-terminal. As this is a YACC, here we are going to use grammar. For grammar, there are terminals and non-terminals. So, in this grammar, we are going to use non-terminal as a exp. This exp is non-terminal. So, we wrote hash type and exp. But this exp is having of type P. P is a double type. So this part is a definition section. Now next section is the rule section, where we are writing patterns or the grammar which is required for our program. So our program is basically scientific calculator. So everyone knows how to write a grammar for addition, subtraction, multiplication and division. In POC we saw E gives E plus E slash E minus E slash E into E divided by E. This is the grammar. Same way we wrote over here. So this is a grammar for arithmetic expression. Same thing, E is giving minus EXP, means this is a unary minus. Then E is giving bracket E, in bracket E. Then sine of E, cos of E, tan of E, log of E, all this way. So this is a grammar part. Here this is a grammar part. But we have to evaluate this expression also. So how it will evaluate in this way. So in bracket we wrote dollar is equal to $1 plus $2. As we already saw, what is the meaning of dollar? Dollar indicates resulting value for any part of the grammar. Means exp is equal to exp into exp, means is before exp, that is the resulting value, and this $1, $2, $3 values from the sub parts of the grammar. So that thing we have done here. So this $, representing this exp, and this $1 is representing this exp, this $3 representing this exp, and this plus is representing $2. This plus is representing $2. So $3, $2, $1, $0. In this way we can say like this. So means this sub part are giving $1, $3 in this way. So this is the actual working. For divide operation, here we are checking the condition. If this is equal to 0, then it will give the divide by 0 error and exit. If it is not 0, means this exp is not 0, then we will write $, is equal to $1 slash $3. Same here, if it is unary minus, then $, is equal to minus $2. Why it is $2? Because this representing $1. Same here, this is equal to $2. Again, this is $2 because this is $1. This is $1 and this one is $3. That's why we wrote here $2 directly. Don't be confused. This bracket is representing $1. This expression is representing $2. This expression representing $3. And this is equal to representing $0, which is hidden over there. Same for this sign exp. Same for this sign. Then $2, $3, $4 in this way. $4, $3, $2, $1, $0 in this way. So this is what actual expressions are evaluating. So this is what our grammar. This is a YACC file and this section is a rule section. Now next section is a subroutine section. Over here we just wrote one function, main function, and in that main function we called yparse and while loop, because we are giving number of time inputs. Enter expression means arithmetic expression or scientific expression, and this input, and then showing the output. If our input is not correct or some bracket is missing, some variables or the identifier which is not present in our grammar, then it will fire the error. That is a syntactical error. So here repeatedly tries to parse the sentence until the input runs out, this way. And finally, this is the error handling, YY error function. So this part is a subroutine section where we wrote main and the. So how LEX and YACC linking is done? So basically, see this example. This is a lexical analyzer LEX. This is a YACC parser. So this is a L file. This LEX is generating lex.yy.c file. Lex.yy.c file using this YYLEX function. Then this YACC, input for this YACC is any file name dot y. Then it is generating y.tab.c and y.tab.h. These two files are generated, and this y.tab.h is required for this lex also. That's why we use this y.tab.h in lex file. And here this is done using YYParse. And then these are the two C files, y.tab.c and lex.yy.c. So we are just compiling these two files using CC or BCC. So compiling, and finally we are getting exe file, that is a.out. This is our output file, and run it. In this way, Lex and YACC linking is done. You can see here. Here, first command is lex. Our file name is cal.l. It is creating lex.y.c. Then next, YACC dash D cal dot Y. Because of this minus D, this Y dot tab dot H file is generated. If we skip this minus D, then only Y dot tab dot C file will generate. So for Y dot tab dot H, we need to write this dash D. So two files are generated by this YACC. And then compile these two C files. lex.yy.c and y.tab.c. cc lex.yy.c lex.y.tab.c minus ly lm. This ll means link lex, link yak and link math library function. And finally this a.out file is generated after this compiling and execute this a.out. Then we are getting the such kind of input. Enter expression. This is my expression. 45 into 67 sine of 45. I will get this answer. Same here. 23 into 56. I will get this answer. Means this 45 is one token. Then star is another. Then 67. For this 45 it will give integer, that number. Then this number. Here this SIN. This token will separate. And using this grammar it will work. In this way we can write our calculator program for simple in simple way. If you like it, please press the like button and subscribe my channel. Thank you.